Hello friends, today we will take some problems on Fourier series. In last video concept is already given. So first example, find the Fourier series of f of x is equal to x square in minus pi is less than equal to x is less than equal to pi, and f of x plus 2 pi is equal to f of x, and hence deduce that these three conditions. So for these three conditions, first we have to find Fourier series of f of x is equal to x square, and here f of x plus 2 pi is equal to f of x means given that f of x is periodic function with period 2 pi. So for Fourier series, first f of x must be periodic function. So this is given in problem. So here f of x is periodic function. You have to find Fourier series in minus pi to plus pi. So here first interval is minus L to plus L, and minus L to plus L given in minus pi to plus pi. Means if we equate minus pi to plus pi with minus L to plus L, then we get the value of L is equal to pi. Now if interval is minus L to plus L, then we have to check first given function is even or odd. Given function is even or odd. So how we check? By putting x equal to minus x in given function. So given function is f of x is equal to x square. In that, if we put x equal to minus x, then we get this minus x square. Minus x square is equal to x square. So we get original function f of x. And from this we can say that f of x is an even function. And if f of x is defined in minus L to plus L, and f of x is even function, then its Fourier series expansion is given by f of x is equal to a0 by 2 plus summation of n varies from 1 to infinity an cos n pi x by L, where this is equation 1. Say here f of x is even and therefore bn is always 0. Bn is 0, then Fourier series is this a0 by 2 plus summation of an cos n pi x by L. So we have to find only two Fourier coefficients here, a0 and an. So where a0 is equal to formula a2 by L, 0 to L f of x dx. What is L? L is equal to pi here. So if you put L equal to pi, then this becomes 2 by pi 0 to pi x square into dx is equal to 2 by pi integration of x square is x cube by 3, limit is 0 to pi, is equal to 2 by pi into upper limit x is equal to pi, so pi cube upon 3 minus lower limit is 0 upon 3, that is 0. So this pi cube upon pi is 1 pi get cancelled, that is 2 pi square upon 3. So this is the value of a0. Similarly we have to find an. So an is, how to find an? Formula an is equal to 2 by L integration of 0 to L f of x cos of n pi x by L dx. Now put L equal to pi and f of x is equal to x square here. So this is equal to 2 by pi into integration of 0 to pi x square into cos of, if you put L equal to pi here, then this pi get cancelled, so x square cos nx into dx. Now how we find integration of this x square cos nx using u into v rule? So you have to use generalized rule of integration by part. If we take suppose u equal to x square, v equal to cos nx, then we know formula integration of u into v is u v1, u as it is, that is x square, v1 is integration of v. So cos nx is integration is sin nx upon n minus u dash means derivative of u, that is derivative of x square is 2x into v2 is integration of v1, this is v1. So integration of sin nx is minus cos nx upon n into n is n square plus u double dash is derivative of u dash is 2x, is derivative is 2 into v3 is integration of this minus cos nx, that is minus sin nx upon n into this n square is n cube, and the limit here x square is from 0 to pi. Now put upper lower limit is equal to 2 upon pi into, if we put here upper limit x is equal to pi and lower limit x is equal to 0, then in Fourier series in maximum problems we get terms sin n pi and cos n pi. So what is the value of sin n pi? Sin n pi is always 0 for all values of n, and cos n pi is equal to minus 1 raised to n, means cos pi, cos 3 pi, means cos n pi equal to minus 1 if n is odd and 1 if n is even. So in general we can write cos n pi is equal to minus 1 raised to n for all values of n. So here if you put upper limit x is equal to pi, then here pi square sin n pi upon n minus minus plus 2 pi cos n pi upon n square minus 2 sin n pi upon n cube. This is the upper limit, and lower limit we put here x equal to 0, so minus sin x equal to 0, 0 into something is 0, minus minus plus again lower limit minus sin x equal to 0, 0 into cos is 0, and last time is minus sign already there, so minus minus plus sin 0 is 0. So lower limit is total 0, and using this sin n pi equal to 0 cos n pi equal to minus 1 raised to n, we can write 2 upon pi into first term is 0 plus 2 pi by n square into cos n pi is minus 1 raised to n and sin n pi is 0. So what is the value of an? An becomes 2 into 2 is 4, and this pi get cancelled, 4 by n square into minus 1 raised to n. So this is equation 2 say, and this is equation 3. Now we have to put 2 and 3 in equation 1. Equation 1 is Fourier series of f of x, that is a0 by 2 plus summation of an cos n pi x by l. And value of a0 is 2 pi square by 3. Value of an is 4 by n square into minus 1 raised to n. So we have to put this a0 and an in equation 1. Then what is f of x? F of x is x square. So equation 1 becomes here. Equation 1 is f of x is x square. So LHS is x square is equal to a0 by 2. Now what is the value of a0? A0 is 2 pi square by 3. 2 pi square by 3 upon 2 plus summation of n varies from 1 to infinity an cos n pi x by l. So an is 4 by n square, 4 by n square into minus 1 raised to n cos n pi x by l. In that if you put l equal to pi get cancelled, so cos nx. So after simplification, this is 2 get cancelled here, pi square by 3 plus this 4 we can take outside series, 4 into summation of n varies from 1 to infinity minus 1 raised to n upon n square into cos nx. So this is the required Fourier series of x square in the interval minus pi to plus pi. Okay, this first part is over here. Now we have to solve, we have to deduce that conditions, additional conditions. In that condition, first condition is we want 1 upon 1 square minus 1 upon 2 square plus 1 by 3 square is equal to pi square by 12. Means we want alternate sign. So this is the hint. When we get alternate sign, we know that minus 1 raised to n is minus 1 and plus 1 for n equal to 1, that is negative, and for n equal to even, that is positive. Means alternate signs are there. So cos n pi means you have to cancel this cos nx, means it, so choose suitable value of x for that first condition. If we put x equal to 0 here, then we get 0 is equal to pi square by 3 plus 4 times summation of n varies from 1 to infinity minus 1 raised to n upon n square into cos 0. Cos 0 is 1. So minus pi square by 3, this term right in LHS, is equal to 4 times, expand this series, for n equal to 1 minus 1 upon 1 square, for n equal to 2 minus 1 square is plus 1 upon 2 square, for n equal to 3 minus 1 cube is minus 1 upon 3 square, for n equal to 4 plus 1 upon 4 square minus so on. And after simplification, this here minus sign if multiply throughout by minus and this divide by 4, so we can write pi square by 12 is equal to this minus become plus 1 upon 1 square minus 1 upon 2 square plus 1 upon 3 square minus 1 upon 4 square plus so on. So this is the first condition. Now for second condition, we want all positive signs. So when we get all positive sign, if we get power of this minus 1 is even, and when we get power of this minus 1 raised to n even, power of this minus 1 raised to n even if we get again one term here minus 1 raised to n. So for which value of x we get minus 1 raised to n, here if you put x equal to pi, then cos n pi is minus 1 raised to n, and minus 1 raised to n into minus 1 raised to n is minus 1 raised to 2n. So for next condition, this is say 3, we have to put, for second condition we have to put x equal to pi in equation 3, not 3, this is 4 in equation 4. So if you put x is equal to pi in 4, then equation 4 becomes pi square is equal to pi square by 3 plus 4 times summation of n varies from 1 to infinity minus 1 raised to n upon n square into cos n pi. And what is the value of cos n pi? That is minus 1 raised to n. So this can be written as pi square minus pi square by 3 is equal to 4 times summation of n varies from 1 to infinity minus 1 raised to 2n. Base is same here, n plus 1 is 2n upon n square. So pi square minus pi square by 3 is 3 pi square minus pi square, that is 2 pi square by 3 into this 4 is equal to expand summation of n varies from 1 to infinity minus 1 raised to 2n even power, that is 1, so 1 upon n square. So after simplification, this 2 by 4 is 1 by 2 into 3 6, pi square by 6 is equal to 1 upon 1 square plus 1 upon 2 square plus 1 upon 3 square plus so on. So this is the second condition. And third condition is, in third condition I think 1 upon 1 square is there, 1 upon 3 square means even terms are missing. So if you take addition of 1 and 2, adding first and second, then we get third condition. So if you take addition of first and second means these two, pi square by 12 plus pi square by 6, pi square by 12 plus pi square by 6 is equal to, if you take addition 1 by 1 square plus 1 by 1 square is 2 by 1 square, this minus 1 by 2 square plus 1 by 2 square get cancelled, 1 by 3 square plus 1 by 3 square is 2 by 3 square and so on. So if you take LCM 6 here, so you have to multiply by 2, so 2 pi square plus pi square is 3 pi square by 12 is equal to 2 into 1 upon 1 square plus 1 upon 3 square plus so on. So 3 by 12, that is 1 by 4, and this 2 8 means pi square by 8 is equal to 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square plus so on. So this is the first problem. Only up to Fourier series this problem is important. Means how to find Fourier series of f of x is equal to x square in minus pi to plus pi. So answer is this. Okay, and this is the deduction of that Fourier series. Now we will take one more problem, that is example number 2 is find Fourier series of f of x is equal to x cube in minus pi is less than equal to x is less than equal to pi. So again interval is minus L to plus L, and given interval is minus pi to plus pi, so L equal to pi. Minus L to plus L is, we have to check given function is even or odd. How we check? By putting x equal to minus x. So f of minus x is equal to minus x cube, and minus x cube is minus x cube, that is equal to minus time f of x, and therefore f of x is an odd function. And if f of x is odd function, then value of a0 and an is always 0. So we have to find only bn. Its Fourier series expansion is f of x is equal to summation of n varies from 1 to infinity bn sine n pi x by l. This is equation 1. So here we have to find only one coefficient, Fourier coefficient, that is bn. So how we calculate that? Bn is equal to formula 2 by l into integration of 0 to l f of x sine n pi x by l dx. So l equal to pi here, put, that is 2 by pi into 0 to pi f of x, say x cube sine nx into dx, because if you put l equal to pi, pi get cancel. And how we take integration here? Using u into v rule. Take u equal to x cube, v equal to sine nx, and use generalized rule of integration by part, that is u v1 minus u dash v2. So if we take u is equal to x cube into integration of sine nx is minus cos nx upon n u v1 minus u dash derivative of x cube is 3x square into v2 integration of minus cos nx is minus sine nx upon n into n square, plus signs are alternate. Take derivative of this term, integration of this term. So derivative of 3x square is 6x, and integration of this one is minus plus cos nx upon n cube, minus derivative of 6x is 6, and integration of cos nx is sin nx upon n into n cube is n raised to 4, and limit is x varies from 0 to pi here. So if you put upper and lower limit here, upper limit x is equal to pi, then we get minus sine pi cube into cos n pi. Cos n pi is minus 1 raised to n upon n, minus minus plus 3 pi cube sin n pi. Sin n pi is 0, plus 6 pi into cos n pi. Cos n pi is minus 1 raised to n upon n cube, minus 6 into sin n pi. Sin n pi is again 0. So this is the upper limit. Now lower limit minus sin n, lower limit minus, that is plus x equal to 0. 0 into cos 0 is 0. Same here, x is multiple, so 0. Here also x is multiple, 0. And here sin 0 is, so sin 0 is 0. So lower limit is total 0. So after simplification, we can write here 2 by pi into minus pi cube, minus 1 raised to n, take common here. So minus pi cube upon n plus 6 pi upon n cube is equal to 2 into minus 1 raised to n upon pi, and you can take pi common here. So minus pi square by n plus 6 by n cube. So this pi get cancelled. So value of bn is 2 into minus 1 raised to n upon n cube. Take common from this. If you take n cube common, we have to multiply here n square. So answer is 6. We can take n cube common, so 6 minus pi square n square. So this is the value of bn. We have to put in equation 1. Therefore required Fourier series of x cube in interval minus pi to plus pi is summation of n varies from 1 to infinity bn, that is 2 into minus 1 raised to n upon n cube into bracket 6 minus pi square n square into sin nx. Okay, now you try this problem at home. Take same problem, find the Fourier series of f of x is equal to x cube in the interval minus L is less than equal to x is less than equal to L. Means instead of pi use L only. Here this formula is as it is, use this L only. Okay, thank you.